here, let's say we have 1, 2, 3, 4, 5, 5 parallel straight lines, and we have 3 different inclined lines like this. When we have such a shape or geometric shape, we asked about how many trapezoidals are available, or trapezoids are available in this diagram. So the question is, how many trapezoids inside or within this diagram? This is the question. This question can be solved by counting all the trapezoids. Here, this is 1, this is 1, the bigger one is 1, and so on. Or we start by the bigger ones, then the small one. We have seen students doing so, but this is a bit difficult, and I will teach you a more practical method. For creating a trapezoidal or trapezoidal shape, we need two parallel lines and 2 inclined lines, like this, like what is drawn now here. So this is the parallel. Here we have 2, and we have here inclined lines also 2. So based on this, so 2 parallel and 2 inclined lines are needed. We can use the combination, or the concept of combination here. Let's count here D1, D2, D3, D4, D5. These are the parallel lines. So D1 is parallel with D2, is parallel with D3, is parallel with D4, is parallel with D5. And here, for these 2 parallel lines, or each parallel line, we need 2 to get the trapezoid. And the same, we have 3 inclined, and 2 among them will create for us a trapezoid. So this will be a multiplication between the combinations of 5, 2 and 3, 2. Combination can be represented by different ways sometimes. So it could be C of NR, or combination of R out of N. So this one is represented by the factorial of N over the factorial of N minus R times the factorial of R. This is the formula, the rule. You should remember it so that you can solve. Here in this case, we can use the formula. The combination of 5, 2, or 2 out of 5 is equal to 10, and the combination of 2 out of 3 is equal to 3. And we can easily use the formula to get the 10 here and 3 here, and this will give us 10 times 3, and that's equal to 30. So 30 trapezoids within this figure, or within this diagram. Also, let's use a different question with the combination, again with the combination and groups or sets. Let's check. We have a set A equals to 1, 2, 3, 4, 5. This is the set, and if this set is given, we are asking about how many subsets from set A have at least two members or 2 elements within them. So we need the number of subsets from set A that have at least 2 elements. So pay attention to at least here. So the count of the number of elements in A is equal to 5, and based on it, the total number of the subsets from set A is calculated by 2 to the power 5. That is the number of elements here So 2 to 5, that's 32, all subsets, all possible subsets. But here, let me remind you with some information about the combinations. Let's have the combination of R out of n, or here we have n and 0 plus n1 plus n2 plus until nn. Combination n out of n, or combination nn. That's equal to 2 to power n. This is a rule, so we should keep this one in mind. Here, also I would like to say another thing. Let's say we have the count of the number of elements of a set is equal to n. Here, at least is the key of solving the question, so at least 2. So this should be considered while solving the question. So at least R, let's say at least R as a general formula, at least R elements for the subsets. Okay, how many? So we need to count. And now based on this, we can translate it to the combination of R out of n plus the combination of R plus 1 out of n, the combination of R plus 2 out of n, plus etc. until n, combination of n out of n. So this is the answer. This is exactly the answer, at least in this case. So this is the key point. So we are asking about at least two elements. So if the question is not asked about at least two, so we need to get all possible solutions. But here we need to get the combination as written, 5, 2, 5, 3, 5, 4, 5, 5. So we need to calculate this. If we pay attention, look at this to the right side. Look at this. Let me remind with those. The combination of 0 out of n, that's equal to 1. The combination of 1 out of n, that's equal to n. The combination of n out of n, that's equal to 1. And the combination of n minus 1 out of n, that's equal to n as well. So these are common about combinations. So combination 0 out of 5 plus combination 1 out of 5 plus combination 2 out of 5 plus combination 3 out of 5 plus combination 4 out of 5 plus combination 5 out of 5 equals to 2 to power 5. This is the common rule given to the right. So what is requested from us is this part actually, from 2 and above, at least 2. So from 2 and above, this is requested. Okay, this is the part that's requested. So if we assume that this is x, then we can substitute 1 plus 5 from these two first terms. This is at least, which is x we are looking for, at least 2 elements. Okay, the 2 elements in the subset. We need the count, plus x equals to 2 to power 5, that's 32. And here x equals to 32 minus 6, and that leads to x equals to 26 different subsets that have at least 2 elements from this set A. Here we have another question that usually appears or comes on this exam. Let's say we have the word frat organized this way. If we start from the F letter and we move until T, how many times we can compose the word frat? If we go from this side, let's say this way, this is one way. We can use another way like this. This is also possible. And based on this kind of network, how many times can we read the word frat? How many ways, or how many ways actually? What's important for us here is we choose a way, we choose one of the ways, either the red or the orange or the yellow. Let's choose the orange. We have this horizontal line, you can say horizontal in this case, and we have this vertical, let's say, in this case. Here we have 1, 2, 3, 4 different ways. So here we go to permutation. So this is factorial 4. So divided by the 2 which belong to the 2 ways for the horizontal, and times 2 which belong to the vertical. So it will be factorial 4 divided by factorial 2 for the horizontal times factorial 2 for the vertical. That's equal to 4 times 3 times 2 factorial divided by 2 factorial times 2 factorial, and that's equal to 6. So we have 6 different ways to read the word frat, and this is possible in this question. This is we give this as an advertisement for our university, but it could be in many different ways. But the logic of answering the question is the same. Let me give you another question. Look at this. Let's say we have a net, or you can say a route like this, a map for, let's say, a road in a city. Let's say we have point B and point A and point B and point C, let's say, in a city. And to go from A to B, how many ways, or how many roads in this case, and from B to C? Let's go from A to B first. So how many ways, or how many routes possible? So we have, let's choose this one here. We have 2 different ways. That's factorial 4. So how many of them horizontal, how many of them vertical? So we have 2 horizontal, 2 factorial, times 2 vertical. We have 2 vertical here, 2 factorial also. So factorial 4 divided by factorial 2 times factorial 2 again. So that's equal to 3 times 4 times 3 times 2 factorial over 2 factorial times 2 factorial, that's equal to 6. If we go from B to C, similarly, if we go from B to C, then we would get the same. Let's say 2 horizontal and 2 vertical in this case, and that's exactly 6. The same logic that will produce 6. So this means if we are going from A to B or from B to C, the same routes we'll have. But if we go from A to C, then it will be the multiplication of the possible ways. 6 times 6, 36, moving from A to C. This is possible solution. So the same logic of these 2 questions actually is applied, and there is no difference. We need to count the possible ways, factorial of it, divided by the factorial of the vertical times the factorial of the horizontal. And you may face similar questions by the same logic.